Come down to the waterfront and watch these submarines being assembled. The sight is nothing short of mesmerizing. A new apex predator has entered the ocean. The U.S. has just rolled out its newest submarine, and the details surrounding it are generating real fear. Many people are stunned by its massive size, but that isn't the most frightening part. It's the silence. This machine is engineered to be a ghost, a deep-sea phantom that can't be detected. It's the quietest and most elusive submarine the U.S. Navy has ever created. Today, we're lifting the veil on the technology that renders it nearly invisible and the terrifying firepower it carries. Even more surprising is another hidden submarine program, the SSNX, that's coming right behind it. These are the chilling secrets of the Columbia. Picture the Empire State Building. Now imagine laying it on its side and slipping it beneath the Atlantic Ocean. Do this with no sound, no splash, and not even the slightest ripple. The ocean simply absorbs it. And in the silence that follows, the most terrifying machine ever built by human hands begins its patrol. This machine isn't designed to wage a war, it's designed to stop one simply by existing. Because the power it carries is so absolute, so final, that it makes the very idea of a major global conflict unwinnable. This is the USS District of Columbia, the first of the brand new Columbia-class ballistic missile submarines. And to put it simply, it is a silent ghost armed with thunder. For decades, the United States has relied on its Ohio-class submarines. These were the ultimate Cold War deterrent, quiet, deadly, and constant. But here's the problem: they're aging. Built in the 1970s and 80s, they're approaching the end of their operational lives. And more critically, their nuclear reactors require an extremely complex, costly midlife overhaul and refueling. This process takes the submarine out of the fleet for years, leaving a massive gap in U.S. strategic defense. The Navy knew a replacement was essential, but it didn't just want a better version, it wanted a game-changing leap forward. That leap became the Columbia class, and the numbers behind it are staggering. This isn't merely a warship, it's a submerged mobile fortress built to stay hidden for months, fully prepared to act at any second. It weighs more than 20,000 tons and stretches 560 feet, nearly the length of 2 American football fields. Its beam, or width, is 43 feet. This makes it the largest submarine the United States has ever attempted to build, and the price tag reflects that. The first ship, the District of Columbia, will cost around $18 billion. Each of the following 11 ships will cost about $11 billion. To build something this enormous, the Navy turned to 2 legendary shipyards, General Dynamics Electric Boat in Connecticut and Newport News Shipbuilding in Virginia. It's a massive joint effort. Each shipyard constructs enormous sections of the submarine, which are then transported and joined together like the most complicated, high-stakes puzzle ever assembled. But the true shock factor, the part sending chills through foreign militaries, lies deep inside the hull. At the core of the Columbia is an all-new S-1B nuclear reactor. This reactor is astonishing. It's designed to power the submarine for its entire 40-plus year lifespan without ever being refueled. Think about that. Ohio-class submarines needed to return home for years during refueling overhauls. The Columbia never has to. From its launch to its retirement 4 decades later, its power plant is set for life. This single improvement dramatically boosts its availability and is projected to save around $40 billion in support costs across the fleet. But even that isn't the most intimidating aspect. What's even more remarkable is how that power is used. The reactor generates enormous amounts of steam that spins turbines. On older submarines, those turbines connected to large, intricate reduction gears that turn the propeller shaft. No matter how finely crafted, those gears clicked and whirred. That mechanical noise was a submarine's sonic fingerprint, exactly what enemy sonar crews listened for. The Columbia eliminates gears entirely. It is the first American ballistic submarine to use a full electric drive system. The reactor's turbines power a generator that produces huge amounts of electricity. That electricity quietly drives a massive electric motor, which turns a pump jet propulsor. Fewer moving parts means less noise, less wear, and a sound profile that melts into the natural background noise of the ocean. To an enemy searching for it, the sub doesn't sound like a machine. It sounds like nothing at all. Then there's the firepower. Beneath its deck, the Columbia carries 16 enormous launch tubes. Each one houses a Trident II D5LE missile. LE means life extended, and these missiles are, quite literally, capable of ending civilization. Each missile has a range of more than 7,000 miles and can carry multiple independently targeted warheads. This means a single submarine, hiding silently anywhere on Earth, can strike more than 100 different targets across multiple continents with extreme precision in under half an hour. The Ohio-class subs before it carried 24 missiles. The Columbia carries only 16. This may sound like a downgrade, but it's not. It's a smarter, more optimized design. The Navy realized 16 missiles provide more than enough deterrent power, and reducing the number makes the submarine quieter, more advanced, and harder to detect. The missile compartment was co-developed with the United Kingdom, which will use the same design in its new Dreadnought-class submarines. But many people misunderstand the true purpose of this ship. It's not a hunter, it's not a attacker. Its mission is to disappear. It will leave port and vanish for 90 days or more. Its sole responsibility is to remain hidden and await a command that everyone hopes is never issued. It is the nation's ultimate insurance policy. For any rival power, this is an absolute nightmare. Their commanders know this specter is out there. They know it could be 500 miles offshore or just 50. They can invest billions into sonar networks, hunter-killer subs, and reconnaissance satellites, but they're still searching for a whisper inside a storm, a shadow in absolute darkness. The Columbia class ensures that no matter what happens, no matter how a conflict begins, the United States will always retain the final say, and that final say is catastrophic. But this apocalyptic force is only half the story. The Navy is also developing its hunter, the apex predator, and its robotic swarm. While the Columbia is designed to hide and wait, the U.S. is simultaneously building its opposite, a submarine meant to actively stalk. It is a pure predator, a hunter engineered to track and eliminate the enemy's most important ships and submarines right in their own waters. For now, it's known only by a code name, SSNX, or Attack Submarine Experimental. But the X doesn't mean prototype. It means the next evolution. To understand why the SSNX is groundbreaking, you first have to look at its predecessor, the Virginia class. The Virginias are the workhorses of today's Navy. At 377 feet long and roughly 7,800 tons, they are fast, powerful, and exceptionally quiet. Designed after the Cold War, they weren't built for a single mission. They were engineered to handle almost anything. And they compact with astonishing technologies. One of the most famous is the photonics mast. For a century, submarines relied on periscopes, long metal tubes filled with lenses and mirrors that physically had to break the surface. The problem? Periscopes extended into the control room. That meant the control room had to be cramped into the upper deck, directly beneath the sail. The Virginia class eliminated this. Instead, it uses photonics masts.
These towers are high-tech camera masts equipped with high-definition imaging, infrared vision, and low-light capability. They transmit everything through a fiber optic line, and because of this, the control room no longer has to be fixed to the upper hull. Engineers moved it down 2 full decks into a much larger, more open compartment. Crew members described the change as going from peering through a narrow straw to watching a massive widescreen IMAX display. The relocation also makes the submarine safer, placing its command center deep inside the most heavily protected part of the vessel. Virginia-class submarines are also heavily armed. They carry 4 torpedo tubes capable of firing Mark 48 heavyweight torpedoes, weapons built to track enemy submarines or break the spine of a major warship. But in the bow, they also house 2 enormous 87-inch payload tubes. Each of those tubes can load 6 Tomahawk cruise missiles, long-range weapons able to travel more than 1,000 miles to strike a single building deep inland. The Virginia-class can also use these tubes to deploy Navy SEALs in a mini-sub or launch unmanned underwater drones. It is the ultimate multi-purpose tool. But here's the problem. The world has shifted yet again. Navies are no longer focused primarily on coastal operations and special missions. We've returned to an era defined by competition between major powers. The U.S. Navy is once again preparing for the possibility of conflict in the vast, deep waters of the Pacific or the North Atlantic. And that requires more than a versatile tool. It requires a predator. That predator is the SSNX. The SSNX is being designed to incorporate the strongest elements of all earlier submarines. The Navy wants the speed and firepower of the old, ultra-powerful Seawolf class, the silence and cutting-edge sensors of the Virginia class, and the never-refueled reactor and year-round availability of the Columbia class. It will be a giant, exceeding 10,000 tons, and it is intended to become the fastest and quietest hunter-killer submarine ever conceived. But its true strength won't come from torpedoes alone. Its power will come from its intelligence. The SSNX is being created as a deep ocean mothership. This is where a concept that once sounded like science fiction starts becoming frighteningly real. Picture this. A conflict begins in the South China Sea. A U.S. SSNX sits 100 miles from an enemy fleet, resting 500 feet below the surface, producing absolutely no detectable noise. Its torpedo room isn't just filled with torpedoes, it's a horizontal payload bay that can be reconfigured at will. The submarine releases a swarm of 50 unmanned underwater vehicles, or UUVs. These drones are its robotic wolf pack. They spread outward, quietly sharing information through a hidden network. Some are small scouts, listening for acoustic signatures. Others are decoys, boldly pushing forward to draw enemy attention. A few are larger, long-loitering drones armed with torpedoes of their own. Meanwhile, the SSNX itself remains completely silent. It doesn't use its own sonar at all. It simply stays motionless, 100 miles away, gathering intelligence from its robotic swarm. Its groundbreaking new combat system, powered by artificial intelligence, absorbs terabytes of sensor data every second from the entire network. It analyzes sonar traces, magnetic fields, and pressure disturbances to create a flawless 3-dimensional map of the entire battle space. The AI identifies the enemy's carrier and its destroyer escorts. Sitting in a calm, silent control room, the commander gives the signal. The SSNX doesn't launch a single weapon of its own. Instead, it transmits orders to the robotic wolfpack. 20 miles away, the loitering UUVs awaken, lock onto their targets, and unleash their strikes. Chaos erupts in the enemy formation. They are hit from several angles at once by weapons that seem to materialize out of nowhere. They desperately search for the submarine that attacked them, but there isn't one anywhere near them. The real attacker, the SSNX mothership, remains 100 miles distant, silent and untouched, already retrieving its surviving drones and slipping away into the deep. This is called decision superiority. It means seeing first, understanding first, and acting before the enemy even realizes they have been spotted. This represents the future of undersea warfare. The SSNX won't just be a hunter, it will be the invisible commander of an entire robotic fleet beneath the waves. But how do these machines, the Columbia and the SSNX, actually stay hidden? The secret isn't only quietness. It involves turning the submarine into an acoustic black hole, the science of silence. So how can a 20,000-ton, 560-foot-long steel giant completely vanish in the middle of the ocean? It sounds impossible, but it relies on techniques the Navy has spent more than 70 years perfecting. Ultimately, the submarine must defeat the 2 ways it can be detected: active sonar and passive sonar. First, let's talk about active sonar.
This is the one everyone recognizes from films. It's the ping. An enemy vessel sends out a powerful pulse of sound. That sound travels through the water, strikes the submarine, and bounces back to the sender, who listens for the echo. This echo reveals both distance and direction, like shouting into a canyon and hearing your voice return. So how do you defeat that ping? You eliminate the echo. Modern submarines, like the Virginia and Columbia classes, are covered in thousands of specialized anechoic tiles. These aren't simple rubber slabs. They are multi-layered, high-tech synthetic structures, one of the most secretive parts of submarine engineering. Each tile is individually attached by hand. Their function is to absorb incoming sound energy. When an enemy ping hits the hull, it doesn't reflect. Instead, it sinks into the tiles. The sound energy is converted into an incredibly small amount of heat and disappears. To the enemy sonar operator waiting to hear ping echo, all he hears is ping, nothing. Only silence. The submarine has become a sound-absorbing void. The hull is also shaped with curves and angles that scatter whatever tiny bit of sound remains, sending it off in random directions instead of back to the source. But here's the twist. Most submarine hunters avoid using active sonar. The loud ping broadcasts their position to every submarine in the area, including the one they are hunting. So the real battle relies on passive sonar. Passive sonar means just listening. It is a competition of absolute quiet. The hunter sub and surface ships drift silently with extremely sensitive hydrophones. They listen for the faintest unnatural noise, the whir of a motor, the grinding of gears, the tiny popping of a propeller. This is where true acoustic mastery matters, and this is where U.S. submarines are unmatched. To beat passive sonar, engineers must silence every single source of noise. First, the propeller. Traditional propellers spinning fast encounter a major issue called cavitation. As the blades turn, they create tiny vacuum bubbles that then collapse with faint pops. Billions of these micropops generate a recognizable hum. Skilled sonar operators can hear that sound and instantly determine not only that it's a submarine, but often exactly which class. The solution is the pump jet propulsor, now standard on modern American subs. This isn't an exposed propeller. It's a carefully engineered rotor and stator system inside a large, precisely shaped shroud. The duct channels the water smoothly, preventing bubble formation. A small, controlled stream of water is expelled quietly out the back. The small amount of sound it does produce blends so closely with natural ocean noise that it becomes nearly impossible to distinguish. Next is the machinery. A nuclear submarine is effectively a floating, sealed industrial plant. It contains air conditioning units, coolant pumps, generators, CO2 scrubbers, all of which vibrate. If these machines were mounted directly to the hull, the whole vessel would resonate like a giant tuning fork, transmitting noise for miles. To prevent this, engineers use rafted machinery. The entire propulsion system, reactor, turbines, generators, are mounted on massive vibration isolating platforms, meaning none of it touches the main hull directly. Modern subs are built on a massive internal raft suspended by shock absorbers that trap vibration so none reaches the hull or the water. But silence isn't the only way they hide. Enemies can also look for magnetic signatures, so submarines are degaussed, electrically reset to make their magnetic field nearly invisible. The ocean itself helps too. Layers of warm and cold water can reflect sonar, letting a sub hide just beneath a thermal layer, completely unseen. This level of stealth feels futuristic, but it was built over decades of hidden research to achieve the ultimate goal: silence. The Columbia class, the most powerful weapon ever created, is designed with the hope it never fires a shot. Its purpose is deterrence, being so quiet and so capable that war becomes too costly to start. So here's the final question. Does making submarines even quieter and more advanced make the world safer?